So today is the day one of Kubernetes, right? Without wasting time, we can start today's session. So I will start with what is this Kubernetes, okay? So just imagine that you have created one application, okay? And you want to share that application to the world. And how you have created that application? You have used Docker container to package your application. So what is the Docker responsibility? Docker should make my application work regardless of any environment. So you have deployed 3 different servers using Docker. Okay, your application starts getting massive traffic. You are happy because wow, my application is doing better than I thought it would be. Because if you are getting more traffic, you will get more revenue. Right? More visitors, more revenue. So you are happy with that. Right now you have 3 servers. Okay, if the traffic was increased, I need to increase that servers, right? Now you need to scale up fast. How you will go from 3 servers to 40 servers, right? Because there is a hell lot of traffic is getting. That 3 servers cannot able to manage the traffic. You need to increase your servers. And how you will decide which container should go where? Nothing but there are 40 servers. On which servers you need to run which container? That is also a question mark. How you will monitor all containers, right? And how you will restart the container if it is die. This is the main issue now you are facing, right? How am I managing? Okay, I need to create more instances, and he's thinking it's an out of control. So wouldn't it be easier if this behavior was handled by a system? So it will be easy, right, if there is any tool that will manage everything for us. This is where Kubernetes comes into play. Kubernetes, in short form they call it as K3s, is an open source container orchestration platform that automates deploying, managing and scaling containerized applications. So don't worry, I will take control. So Kubernetes will solve this problem. That's the reason Kubernetes became a huge success. Now everyone using this Kubernetes. Okay, what Kubernetes cluster will contains? A Kubernetes cluster consists of set of worker machines called nodes. Right, this is the Kubernetes master and there will be Kubernetes nodes. What it will do? It will run containerized applications. So every cluster has at least one worker node, right? Every cluster will have at least one worker node. Hence, if a node fails, your application will still be accessible from other nodes, right? For suppose this node is failed, other nodes are available, right? Automatically, your application will not have any downtime. Still be accessible from other nodes as in a cluster. So multiple nodes are grouped, right? Every node will be grouped together. So what is the architecture? Every node contains a container runtime, kubelet and kubeproxy. Okay, inside the container runtime your container will be running. There is a kubelet. What kubelet will do? For starting, stopping and managing individual container by request from the Kubernetes control plane. So kubelet will manage your container, okay? And kubeproxy, it will manage the load balancing and networking. So you need to know the architecture of Kubernetes. In Kubernetes there is the master and node components. In the master you will be having kube API server, scheduler, controller manager and etcd. In the interview if they ask, you need to answer what are the components of Kubernetes master and node. What is the architecture of Kubernetes if they ask. In the master you will be having API server, scheduler, controller runtime, etcd. And master only supports Linux operating system. Okay, Kubernetes master only supports Linux, it will not support Windows. And what are the node components? Node supports Linux and Windows both. You will be having kubelet, container runtime, kube proxy, right? Kubelet will manage your containers. Inside the container runtime, your container will be running. Kube proxy will manage your networking. So if you are using Kubernetes less than 1.23 version, right? If you install Docker, for Kubernetes, Docker is mandatory. Okay. While installing Docker Kubernetes, you need to, in the backend you need to install Docker, because what are the container technology we are going to use? We are going to use Docker, right? That's the reason you need to install Docker. Docker is common. If you are using less than 1.23 version of Kubernetes, if you install Docker, that is more than enough. But if the now latest version of Kubernetes supports all, in the past Kubernetes only supports Kubernetes Docker technology. Right now Kubernetes support every container technology. That's the reason Kubernetes changed their installation, right? Now it is recommending to install cryodockerd. What is this? All these things you will learn. Okay. Now you got some clarity, right? What is Kubernetes? How it is solving the problem. Okay. Why to choose Kubernetes? Why I need to choose Kubernetes? One is high availability. When we run our application in Docker container, and if the container fails, we need to manually start the container. Obviously, if you are running a container, you need to start manually. If the machine fails, all the container running on the machine should be recreated on other machine. Yes. Kubernetes can do both of the above. That's the reason you need to choose Kubernetes. Kubernetes will do it for you. Auto scaling. Container don't scale on their own. Scaling is of two types: vertical scaling, horizontal scaling. Kubernetes can do both horizontal and vertical scaling of containers. For that reason, you need to choose Kubernetes. Zero downtime deployment. Kubernetes can handle deployment with near zero downtime deployment. Zero downtime, nothing but your application will not go down. Kubernetes can handle rollout and rollback. Nothing but Kubernetes can upgrade to the newer version, and it can go back to previous version as well, older version as well. That also supports Kubernetes. And Kubernetes will call it as production grade container management. So you need to know the history of Kubernetes, right? How this Kubernetes was born. Google had a history of running everything on containers. The Google search engine you are using, right? In the backend, it is run as a container itself. To manage these containers, Google has developed a container management tool, which is Borg Omega. Right? In the backend, Google was using Borg and Omega as a container technology to manage the Google search. Right? With Docker publishing container, with the experience in running the managing container, Google has started a project Kubernetes. Right? Just a moment. Yeah, Darshan, try to join before 9.
Oh, yes, sir. Sure.
So Google know this is the successful container technology. Then after what Google has decided, they have very much experience in running this managing container. So Google has started an open source project, which is called as Kubernetes, which was developed in Go language. After that, they have handled it to Cloud Native Container Foundation. So this is the company which manages open source tools. So Google has developed this Kubernetes project. Then after, they have donated this Kubernetes to Cloud Native Container Foundation. So that's the reason it has become an open source. They make it Kubernetes free. Google has developed. still Google using their, so with the experience of their inbuilt tools, they have developed this Kubernetes. Okay, still they are using this itself, Borg and Omega, for their Google search. But Kubernetes and Borg and Omega both are same. Okay, they have, by using this experience, they have created their new project, and they have donated to Cloud Native Container Foundation. So obviously there will be competitors, right? Once the Kubernetes came into this market, there will be other companies who want to become a huge success by competing Kubernetes. So Apache Mesos is this also a type of Kubernetes. Archicop Nomad, Docker Swarm. But Kubernetes is a clear winner. Even though if there are competitors, still Kubernetes has a winner, because it's developed by Google. Obviously everyone will automatically, they will prefer Kubernetes, and still Google search engine running as a container itself. So Kubernetes is not designed only for Docker. Okay, initially Kubernetes used Docker as a main container platform. I told you, right, initially Kubernetes has taken Docker as a main container platform, and he has used Docker as a container technology. So from Kubernetes 1.24, special treatment is stopped. So Kubernetes is designed to run any container technology. So now there will be many Docker was created. Okay, Docker will be also a competitors, right? Same like Docker, there will be another companies will be also there, like Rocket. There will be some Docker technologies will be there. So now Kubernetes support all technologies, any technology, any container technology. For this, Kubernetes experts container technology to follow Kubernetes interfaces, nothing but rules, whatever the Kubernetes kept. So this is the Kubernetes official architecture. Okay, you will be having master and nodes. You will communicate your to Kubernetes using kubectl. What is this? You will learn, don't worry. Master components, API server, scheduler, controller manager, etcd. Master supports only Linux. Node components, kubelet, container runtime, Kubectl. Node supports both Linux and Windows. So this is the logical view. Whenever you execute any Kubernetes, right, you will communicate with using kubectl to Kubernetes cluster. Okay, using kubectl you will communicate to Kubernetes. But in the backend, it will happen the actual, this is the actual view. Whenever you execute kubectl, right, the request will go to the API server. Okay, whenever you execute any command, the request will go to the API server. From API server, the request will go to another component. Like that, your container will be created. What is this? You will understand, don't worry. Okay, this is the architecture. Kubernetes, you will be having master and node. In the master, you will be having API server, scheduler, controller manager, etcd. In the node, you will be having kubelet, kubeproxy, container runtime. Inside the container runtime, your container will be running. Now I will explain. So how you will communicate with Kubernetes master using kubectl. Whenever you execute any kubectl command, the request will go to API server. Okay, from API server, the request will go to scheduler. From API server, the request will go to etcd. From API server, the request will go to controller manager. Okay, whatever you do request, first the request will go to API server. Then after it will go to some other. So API server is a front end component. He will manage communication over all the cluster. Right? From scheduler, it will go to kubelet. Kubelet will create a container. Okay, kubeproxy will manage the networking. Now I will explain on each component. So if you see how Kubernetes works, you will write some YAML file, right? User, nothing but a DevOps user will create a YAML file. Using kubectl you will apply, it will go to the API server, right, master, and it will create a pods in the nodes. So control plane components, that is master, you will be having API server, etcd, scheduler, controller manager. If you are using Kubernetes as a service in cloud, then there will be one more component will be added, that is cloud controller manager. What are the node components? Kubelet, kubeproxy, container runtime. So what is this kube API server? Handles all the communication of Kubernetes cluster. I told you, right, it is a front end component. Let it be internal or external. Kube API server exposes functionality over HTTP protocol and provides the REST API. How the communication will happen? Using HTTP protocol. What is this etcd? It's a key value pair. This is the memory of Kubernetes cluster. Okay. Whatever you do, everything will be, information will be stored in etcd. What is the scheduler? Scheduler is responsible for creating Kubernetes objects and schedule them on the right node. Okay, scheduler will scan all the servers and check the healthy node, and it will schedule a container in that server. What is this controller? Controller manager is responsible for maintaining desired state. Nothing but have told Kubernetes to create 10 pods. It's controller manager responsibility to create that 10 pods. If the 10 pods is not created, controller manager will check and it will recreate that. Like for suppose I have created 10, right? If one was failed, it's controller manager responsibility, then automatically that one will be recreated so that it will become 10. Right? This reconciliation loop that checks for desired state, and if it mismatches, doing the necessary steps, it done by controller. What is this kubelet? This is an agent. Nothing but whatever container you are creating, kubelet will create. Container runtime. Inside the container runtime, your container will be running. In our case, it is Docker. We are using Docker as a container technology. What is this kubeproxy? This component is responsible for networking for containers on the node. Networking will be managed by kubeproxy. So what is this kubectl? I told you, right, this is the command line that can be installed on the machine from which you communicate to Kubernetes cluster. Using this kubectl is just a CLI tool. I need to communicate to Kubernetes, right? How I will communicate? Using kubectl. I want to eat biryani. How I will do it? I will use Zomato to book. In the same way, I want to communicate with Kubernetes. So there is a tool called as kubectl. I need to install that tool and to communicate to Kubernetes cluster. So this tool is created to make communication with API servers simplified. Nothing but simply you can able to communicate. Simply I can able to book, right, my biryani. In the same way, I can able to simply communicate with API server using this kubectl tool. So this kubectl will also a config file, which is kubeconfig. So we will discuss all these things, don't worry. In the kubeconfig file, what you will be having? You will be having API server information and how to communicate with API server. And kubectl also allows to communication with cluster to create resources. So you can execute this kubectl commands imperatively and declaratively. So what is this imperative and declarative? I think I have attended 2 days back one interview. He has asked me what is imperative and declarative. Imperative is nothing but you will type command. Declarative is nothing but you will write a manifest file, which is YAML file. In the interview, ask what is imperative and declarative. You need to just tell you whenever we write type commands, it is a imperative. You will learn this, don't worry. If you write a manifest file, it's a declarative. So what kubectl will do? Reads manifest and connects to API server. converts the manifest into REST API calls over JSON. So what is Kubernetes manifest? Nothing but this is a YAML file which describes the desired state of what you want in using Kubernetes cluster. What you want to create using in the YAML file you will define. So what is the workflow? CI/CD workflow, right? Whenever developer commits the code, new code, what you will do, you will build that code and you will create an image. You will push that image to registry. Now once the image is ready, I will take that image and I will deploy to Kubernetes environment, right? You can do this using Jenkins, right? There is a node, you will build the image, right? You will push the image to Docker Hub, and there will be another node you will deploy into the Kubernetes cluster. All these things I will show you, don't worry. So you can do, in the place of Jenkins, you can use AWS Devops as well. Okay, using AWS Devops also you can create a Docker image and you can deploy it to the Kubernetes cluster. So if you are using Kubernetes as a service, all popular clouds are offering Kubernetes as a service, right? Azure providing as a Azure Kubernetes service, AWS providing as a Elastic Kubernetes service, Google providing as a Google Kubernetes engine, right? All cloud providers manage control plane for you and they charge hourly. For nodes we pay the similar cost of virtual machine. So if you are using cloud as a service, as a Kubernetes, Kubernetes master will be managed by cloud provider. You will be having the control of only nodes. Master will be managed by cloud provider. So how you will package application to run on Kubernetes? I told you, right? We will going to package our application and you will run the Kubernetes. Kubernetes can manage. How it will be done? Okay. You will write a deployment, right? Inside the deployment you will be having pod. Inside the pod there will be container. Inside the container your application will be running. So what is the use of deployment? You can scale, you can do updates and you can roll back. What is pod? It's an atomic unit of deployment in Kubernetes. Inside the pod your container will be running. Inside the container you will be having the official application. So what is this? You will learn. So first you will package your application as a container image. So we will create an image for the application. We will push that image to Docker registry. Then using that image you will create a pod. So pod will be deployed inside Kubernetes cluster via declarative manifest file. So what next? We are going to see Kubernetes installation, right? Tomorrow I will show real-time Kubernetes installation. As I said, right, I have already created one server which I have given a name as K3s. I have taken T2 medium. So I will show you basic Kubernetes cluster, how to install this Kubernetes cluster. So first I will log in into this server. How to create this EC2 instance, if you don't know, I have already provided a video in my YouTube channel, you can check. I don't want to waste my time by showing how to create an EC2 instance. Okay. Now what I will do, K3s install. Installation. Using how to set up K3s Kubernetes cluster on Ubuntu 22. Okay, let me go to DigitalOcean. I will copy this command. Okay, then after I will execute this. right? K3 is active and running. This is the lightweight Kubernetes. Using K3s, you can create a lightweight Kubernetes. Now, I will execute. So, I have executed sudo kubectl get all -n kube system. Okay. How Kubernetes master and node components? So, it's still creating. Okay. If I execute kubectl get ns, permission denied, obviously I need to use sudo. So kubectl get ns nothing but namespace. What is this namespace? We will learn. Okay, don't worry. Kube system, kube public. So whatever you deploy, right, application, it will be run as a pod. So I will execute sudo kubectl get pods. So no resources found in the default namespace. Now I will execute -n kube system. Okay. What are the master and node components? Everything will be run on this kube system namespace. Okay. This is the basic Kubernetes cluster. And these are the configuration kubectl get all we already executed. So you can ignore all this. Simple 2 steps if you want to install Kubernetes using K3s. If I execute sudo kubectl get nodes, right? Control plane, only master was installed. Using K3s, you will get only master. Okay. Using K3s, you will get only control plane, which is master. Right? Sudo kubectl API resources. Okay. Using Kubernetes, these are the resources you can able to create. Okay, you can create persistent volume claims, you can create persistent volume, you can see the nodes, you can see the namespaces, right? You can create a pods, you can create a services, you can create a replica sets, you can create a deployment, daemon set, stateful sets, you can create jobs, you can create cron jobs, you can use Helm charts, you can create roles, you can create ingress. So all these things we will learn. Okay. Most commonly used Kubernetes resources we will going to learn from tomorrow. So you know how to install this K3s, right? Just search K3s install. You will find the DigitalOcean article. Go there. Just execute 2 commands. Simply your Kubernetes cluster will be created and it will be used only on the development environment. Okay, this Kubernetes cluster K3s will be used only for development environment because you will get only master components, only Kubernetes. If you want to do some POCs, right, you can use this K3s, but in real time this is not the official Kubernetes cluster. What are the real time you are using, I will show you that. I have already updated class notes. You can go to github.com/DevOps easy. There if you go to repositories, you can find the Kubernetes. So here if I go to Kubernetes day 1, so whatever we have discussed here, right, why we need Kubernetes, high availability, zero downtime, what is the history of Kubernetes, So Kubernetes is not designed for only container. What is the Kubernetes architecture, right? What are the master component? What is the node component, right? Using kubectl will communicate to master, right? Using kubectl request will go to API server, right? You will be having nodes. This is the logical view, but this is the actual view. Control plane components, node components, everything explanation. So what is this kubectl? This is the command line tool, right? How you can create a CI/CD pipeline. This is the CI/CD pipeline. Okay, if you are using Kubernetes as a service, how you will package the application. So everything was provided. If you go to day 2, right? If you want to install Kubernetes single node installation, you can use Minikube as well. Using Minikube also you can able to install this Kubernetes cluster. There also you will get only control plane, only master. Okay, or you can use K3s or you can use kind as well. On-premise installation, nothing but real time. You will use kubeadmin, or you can use Kubernetes as a service as well, which is EKS, AKS, and GKE. Or you can use playground, Kubernetes playground. Right, this is the Kubernetes playground. I will use Docker. So this is free website where you can practice. But invalid request. Okay, I need to log in. Okay, you need to have a Docker Hub account for this. Okay, I will log in. Now I will try again. Log in using Docker Hub. Okay, because it's a free tool, right? Sometimes it will fail. How you will be having Docker playground, in the same way you will be having Kubernetes playground as well. Okay, leave it. So installing Kubernetes cluster or Ubuntu VM, create 3 Ubuntu VMs, right? This is the Kubernetes installation using a shell script. If you want to install Kubernetes by using shell script, you can implement this. Now what I will do, vi k3s.sh. I will show all these things tomorrow. Okay. I will just simply come out sh // k3s.sh. So as I told you, right, if you are using a Kubernetes cluster less than 1.23, then only Docker installation is okay. But if you are using greater than 1.23 version, cryo dockerd is mandatory. So using kubectl, you will communicate with the API server. So whatever you create, everything, it will be stored in the etcd. I have already shown you, right, kubectl API resources. If you execute kubectl get nodes. So in the Kubernetes, you will create a pod. Pod will be created in the namespace. Inside the pod, you can create multiple containers, okay? But inside the pod, you can create multiple containers, but Kubernetes is not recommending. You need to run only one pod or one container inside a pod. So this is the workloads. You will be having replication controller, deployment, pod, service, ingress, storage. These all things we will learn. Okay. Now, first I will install Docker. If I will explain this shell script. Okay. In order to install Docker, right? These are the steps. Then after, I told you, right, if you want to install Kubernetes, now Kubernetes required cryo dockerd, right? Once Docker was installed, I need to install cryo dockerd as well. So to install cryo dockerd, what is the steps? Cryo dockerd installation. You need to download that cryo.docker deb file, right? You need to execute this, then your cryo.docker will be installed. Then after you can install Kubernetes.
Oh, what is that crying out?
It's type of a Docker technology, updated version of Docker technology.
Okay.
So which we will discuss, don't worry.
Okay.
Okay, Kubernetes was successfully installed. Now sudo -i. I will execute kube adm init. Sorry, typo. I will execute kube adm init. So found multiple CRI endpoints on the host. Please define which one do you wish to use by setting cry socket field in the kubeadm configuration file. To see the stack trace error, execute with -v5. So whenever you get an error, right, just simply copy this, paste in the Google. So there will be multiple members who are going to help you. Right, whenever I execute kube init, I am facing this error, right? Because I have installed K3s, right? Then after I have installed kubeadm. So nothing but I am using two components in the same server. And let me show you that kubeadm init will not work out. Right, you need to give this, use the command pod network CIDR and cryo socket. Please define which one do you use, setting cryo socket. Yeah, so this is the cryo socket, right? I am giving same URL unix -f cryo socket and the range, enter. Right, port 10259 is in use. Obviously, if you see kubectl get nodes sudo, already I've created a Kubernetes cluster. That's the reason this port was already in use, is in use. That's the reason I cannot able to create the Kubernetes cluster. Right, you need to remove this K3s, then only you can implement this. This thing I will show you from scratch from tomorrow, right? From tomorrow we will repeat the same thing. So
Are you setting a path for it first or
sorry,
giving that command? Are you setting the path for that to install Kubernetes QADM like given?
I didn't get you.
Like what I thought you were giving the path for to install the Kubernetes in our system. Are you are installing commonly?
Okay, that's it for today. Let me stop the recording.